G'day, stargazers, and welcome to the show. Tonight, we're taking a trip, not to the beach, not to the outback, but to the deepest, most spectacular corners of our universe. We're going on a journey to explore some of the most beautiful and mysterious objects out there. I'm talking about nebulae. These are vast, sprawling clouds of dust and gas floating in the immense emptiness of space. They are the universe's own art studio. What exactly are these things made of? The answer is surprisingly simple. About 99% gas and 1% dust. But this isn't the kind of gas you put in your car or the dust bunnies under your bed. The gas is mostly hydrogen, the most abundant element in the universe, followed by helium. These are the simplest atoms, the primary building blocks left over from the Big Bang itself. The dust component is the interesting 1%. We're talking about microscopic grains made of heavier elements like carbon, silicon, oxygen, and iron. Nebulae are mind-bogglingly enormous. These clouds can be dozens or even hundreds of light years across. The total mass of a large nebula can be millions of times the mass of our sun. Let's begin our tour in the darkest, coldest, and loneliest places in the galaxy. We're talking about dark nebulae, or as astronomers often call them, molecular clouds. When you look up at the Milky Way, you see dark patches and rifts running through it, places where the stars seem to be missing. These aren't holes at all. They are incredibly dense clouds of gas and dust. Once a dark molecular cloud begins to collapse, things start to heat up. The dark, silent cloud is about to burst into a blaze of glorious color. It's about to become an emission nebula, one of the most spectacular sights in the entire universe. Hydrogen atoms primarily emit a very specific deep red light known as hydrogen alpha. This is why so many of the most beautiful pictures of emission nebulae are dominated by stunning shades of red and pink. Not every star born inside a nebula is capable of setting the whole cloud aglow. Sometimes, they create something more subtle and ethereal, a reflection nebula. These are the ghostly blue whispers of the cosmos. The light simply scatters off the tiny microscopic dust grains, giving the cloud its characteristic cool blue glow, the same reason that Earth's sky is blue. All it takes is a little push to upset the delicate balance and start the process of creation. This push could come from the shockwave of a nearby supernova explosion, triggering a widespread collapse. Another common trigger comes from the grand dance of galaxies themselves. As molecular clouds pass into spiral arms, the increased gravitational pull squeezes the cloud, triggering its collapse. Once the initial trigger has compressed parts of the molecular cloud, gravity takes over. The cloud begins to fragment, breaking apart into smaller, denser, and more chaotic pieces. As these fragments collapse, they begin to spin faster and faster, forming a rotating flattened structure, a protostellar disk, from which planets will eventually be born. The protostar has spent 500,000 years gathering mass. The temperature soars past 10 million degrees Celsius. At this point, a threshold is crossed. Nuclear fusion begins. This is the moment a protostar becomes a true star. A star is born, emerging from its dusty cocoon as a self-sustaining, light-producing powerhouse. Our star has found its cosmic comfort zone. For about 90% of its entire existence, a star will be on the main sequence, happily fusing hydrogen into helium in its core. It's a period of beautiful equilibrium. How long this adulthood lasts depends entirely on the star's mass. Massive stars burn bright and die young in just a few million years. Our sun will last 10 billion years. Red dwarfs can shine for trillions of years. Throughout its life, a star continually emits a stream of charged particles called the stellar wind. For massive hot stars, this wind is a cosmic hurricane, pushing gas and dust farther away. Over millions of years, stellar winds can blow enormous cavities in nebulae, creating what astronomers call stellar bubbles. The Bubble Nebula is a perfect example, a single massive star blowing this incredible bubble with its ferocious stellar wind. All good things must come to an end. The inevitable crisis arrives when the star runs out of hydrogen fuel in its core. Without outward pressure to counteract gravity, the star swells into a red giant. When our own sun reaches this stage in about 5 billion years, it will swell up to engulf the orbits of Mercury, Venus, and possibly even Earth. It will be the beginning of the end for our solar system. While swelling into a red giant, amazing alchemy happens in the core. The star becomes a factory for forging heavier elements. carbon, oxygen, and in massive stars all the way up to iron. In the final days of a massive star's life, its core is nested shells, each fusing heavier elements. The calcium in our bones, the oxygen we breathe, all was cooked up inside a massive star. For stars like our sun, the end is graceful. They shed their outer layers into space, creating one of the most beautiful objects in the cosmos, a planetary nebula. The hot, dense core left behind, a white dwarf, illuminates this expanding cloud of gas. Planetary nebulae come in a bewildering array of shapes: simple spheres, beautiful rings, and complex butterfly structures. But their beauty is fleeting, fading in just tens of thousands of years. For the true giants, stars more than 8 times the mass of our sun, the finale is anything but gentle. When their nuclear furnace shuts down, the result is a catastrophic supernova explosion that can outshine an entire galaxy. The Crab Nebula is a perfect example, the remnant of a supernova seen by Chinese astronomers in 1054. These chaotic expanding debris fields seed the galaxy with heavy elements needed for future planets and life. Whether through gentle planetary nebulae or violent supernovae, the material once locked inside stars returns to interstellar space. This enrichment is fundamentally important. It took generations of stars to seed the cosmos with elements needed for rocky planets. This recycled material will eventually gather into new molecular clouds, seeded with the potential for complexity. The cycle begins again, ready to form new generations of stars and planets. The iron in your blood, the calcium in your bones, the carbon that forms the basis of all life. Every heavy atom in your body was forged in a massive star that died billions of years ago. We are, quite literally, made of stardust. We are living on a precious piece of recycled stardust made possible by billions of years of cosmic evolution. The story of nebulae is our story, connecting us to the universe in the most intimate way possible. Throughout our journey, we've focused on incredible science, but let's appreciate these objects for what they also are: sources of profound beauty and boundless wonder. Every new telescope reveals nebulae in ever more stunning detail. When we gaze upon the pillars of creation, we connect with something deep within the human spirit. The aesthetic appeal and scientific inquiry go hand in hand, each enhancing the other. The next time you look up at the night sky, don't just see pinpricks of light. See the vast clouds of gas and dust between them, the stellar nurseries where new suns are born, and the glowing ghosts of stars that have died. Understand that you're looking at the great cosmic engine of creation and recycling that made your existence possible. The journey of the nebula is the journey of everything, and that journey continues tonight in the grand, beautiful theater of the cosmos. Thanks for joining me on this trip. Keep looking up,